So we're looking today at the conversion between truth tables, Boolean expressions, and circuit diagrams. On the web page here, there's a simple example worked through. We discussed the SOP method and the POS method. And what we're going to do in this video is look at a more complex method. And so this is taken from All About Circuits, which you can click on from the website. But basically what they do is they give a scenario where there's an industrial sort of incinerator. There's 3 sensors, and depending on combinations of sensors, the waste shutoff valve should be on or off. They summarize those combinations in this truth table, and our job is to build a circuit for that truth table. So the first thing we need to do is we'll take a copy of that. Put it in here. Hopefully we'll put it in here. Okay, so that will appear in a minute. And okay, so that's come up. So what our first task is to decide whether we use SOP or POS. Now you can see that there's 4 lines with a 0 and 4 lines with a 1, so we can choose. And normally when you're given a choice, you'll always pick SOP, and we will do that. We'll pick SOP. So we'll be concentrating on this line, this line, this line, and this line. Okay, so they're the lines we'll be concentrating on. So we will write down the conditions there, and we will go through, use some algebra to simplify the formula, and then we'll actually draw the diagram. So the first line says, the first line here, it says not A, B, and C, and so we just write that in, not A, B, and C. Or second line says A, not B, C, A, not B, C. Third line says A, B, not C, A, B, not C, or the fourth line says A, B, C. So we'll be using like the rules of algebra we went through earlier, but basically what we're going to do to start with is we're going to grab this one, and we'll use BC factorized by BC, so let's write that out. So not, let's not go to start, BC outside of not A plus, or I should say, A, and we write the others out, A, not B, C, or A, B, not C. Okay, so we've got that now. This thing cancels itself out, so we're left with B, C, or A, not B, C, or A, B, not C. And so maybe the next thing we'll go for will be to, maybe we'll grab this one and this one. Okay, so we'll go common factor is B outside of C plus A, not C, and then we still have to bring this one down. So we go A, not B, C. Okay, now we go B outside of C plus A, not B, C. All right, good. So that becomes B, C, or B, A, or A, not B, C. So now what we might do is we might go this one and this one. So we will go B, C, or the common factor is A there. So we go A, B plus not B, C, which means B, C, or A outside of B or C. Gives B, C, or A, B, or A, C. And this is really the simplified condition. So this is probably the status we wanted at to actually build a circuit on. So what we can do now is grab a copy of that. So just grab a copy of this, move over to here, and paste it in here. Go to my pointer. Okay, that's coming across. All right, so we've got BC or AB or AC. So to draw that, we need 3 inputs. So we have A, pen's not very happy, A, B, and C. Put it back there, somebody see what might get things lined up a little better. Okay, now, so we're ORing everything at the moment. So AB is ORed, and BC is ORed, and AC is ORed. So sorry, and. So we're anding everything here, right? So AB is ANDed, so we need an AND symbol. And we can see that there is a BC that's ANDed as well. So we'll do another AND symbol. And finally, we can see that the A and the C is also ANDed. So to do that, we will put an AND symbol in the middle here. We might change the color of the pen, but basically we can just do this. Okay, and so then what we notice is that there are ORs between these, so we need to OR these. So you can do an OR symbol. Okay. Back to black, back to black. An OR symbol. And what you can actually have is OR gates with 3 inputs. So that's what we'll do for this one. And so that's our output there. And so this diagram that we've just drawn is, or would be, an effective control circuit for our problem. So if we built that into this incinerator, it would be true for our truth table. And so this is a more complex exercise in converting a truth table to ultimately a formula and then its subsequent circuit. Okay, thank you.